Hello, here we are in Chapter 8, Section 6. This is our last section of college algebra. This section we'll be covering systems of equations, and we did this in 8.1 as well, but in 8.1 they were all linear systems, meaning both equations were both lines, and so they basically just crossed at one place, no place, or every place. So in this one, you could have a parabola, a quadratic equation, with a linear. And if you can just kind of visualize that in your head, you could have a line and a quadratic intersecting at no places. They could cross at one if the line is tangent to the parabola. They could cross at two places. Okay, but there won't be an infinite number of solutions because you cannot have a line laying on top of a parabola because they're two different types of graphs. So that's the idea. Now you could have two parabolas, and when you have two parabolas, you could have several different situations where the parabolas don't cross, which means they'd have no common solution. You could have them crossing at one place if they're tangent to each other. You could have them crossing at two places, which is the most common. And if they are the same parabola, then they would be laying on top of each other. So in this section here, we have two objectives, and we're going to be solving nonlinear systems by using substitution and solving nonlinear systems by the elimination. Now, as a matter of fact, the elimination is just kind of one step in the process. You can actually call it elimination method if you subtract the equations by eliminating something, but you can also use the elimination method and substitution in tandem. In other words, use the elimination to make it a little more simplistic, and then substitute that into the other equation. So that would be using substitution technique. So let's begin by talking about solving a system of nonlinear equations with substitution. Alrighty, so let's look at this by an example. Alright, so what we're going to do here is we're going to solve a system nonlinear using substitution. And in solving the following, okay, so we got 3x minus y equals negative 2. That's a line. And then we have 2x squared minus y equals 0. And that is a parabola, okay? So it's a quadratic equation with a line. So like I said earlier, if you have a line in a quadratic equation, they can cross at no places if they don't intersect. You can have the line intersecting the parabola at one point, which is tangent, so it'll be one solution. And the most common possibility is when the line crosses the parabola at two places, and that's most common. Alrighty, so let's look at the solution of this. So first, what we're going to do is we're going to notice that the system of equations variable is that how to graph it. Okay, so if we graph each one of these, okay. And what we're going to do is look at the solutions of this equation by the graph. So in this example, we're going to know what the answer is before we even start the problem. Typically, you do not actually graph them because some of the graphs, you won't even know what they are. If I could give you an equation that it would be very difficult to graph with what we have at this point. Okay. So, but these you could probably graph them. So let's look at the graphs of them. Alrighty, so you have the line, which is the blue one, 3x minus y equals negative 2. And so if you solve for y equals going to be 3x plus 2. And so it's the y-intercept of 2 and the slope is 3. Now the parabola is 2x squared minus y equals 0. So that's the one in the pink. So it's going to be y equals 2x squared. So vertex at the origin. So it appears that the two graphs are crossing at negative 1, 1/2 and 1/2, and the other one is at 2, 8. Now, you're like, well, yeah, but 2, 8, you could say, well, I could probably see that one, 2, 8. But the negative 1/2, 1/2, that's kind of in between, and not knowing that's going to be negative 1/2, 1/2, just by looking at the graph, probably not going to happen. So graphing is not really an option of solving these equations, okay? Because typically you're going to be off a little bit, and especially if the intersection point is between the tick marks, the only thing you can do at that point is estimate what they are. Because that could have very well, instead of being negative 1/2, 1/2, that could have been negative 4/7, comma 5/8. And those are both close to the magnitude of 1/2, and you would never know. So graphing is it's a pretty good way to figure out if the graphs are going to cross or not, but actually finding the actual solutions, not so much. So I'm not going to be asking you to graph these every time. I do it here just to show you that what's happening to the two functions. So what we're going to be setting out to do is solve this system, and we know the answer should be 2/8 and negative 1/2, 1/2. So let's look at this, okay? So we're going to use substitution, so 2x minus y, 3x minus y equals negative 2, so y equals 3x plus 2. All right, so that's the blue one. So what we're going to do with that one is we're going to take that y equals 3x plus 2, and we're going to substitute that into the y of the next equation. And so then I get 2x squared minus the y, which is 3x plus 2 equals 0. So it becomes 3x squared minus 3x minus 2. And that factors, 2x squared. 2x squared minus 3x minus 2. That factors to 2x plus 1 times x minus 2 equals 0. And so x would equal to 2, and x equals 1/2. Subtract 1 and divide by 2, and it'd be negative 1/2. So we got negative 1/2 is x, and x equals also the 2. So we're going to use the values of x to solve for y. So if you got y equals 3x plus 2, and we know x is negative 1/2, you put that in. 3 times negative 1/2 plus 2 is positive 1/2. And if x equals 2, then y equals 3 times 2 plus 2, which is the 8. So the apparent solutions are x equals negative 1/2, y equals 1/2, and x equals 2, y equals 8. And we'll check them. Now, checking is not mandatory. I'm just showing you that, you could check them just to make sure they work. So if x is negative 1/2 on both of them, they both equal the right side. Okay, so, and then if you check, so x equals 2, then y equals 8, you check on that one, and it also works for both equations. All right? So each solution checks. The graphs of the two equations intersect at the points negative 1/2, 1/2, 2, 8, as shown in this figure 9 again. So I'm just going to pull the same graph up from the previous slide just to remind you that the two graphs were supposed to cross at 2, 8 and negative 1/2, 1/2. Okay? So the substitution works exactly the way substitution worked back in 8.1. The only thing different here is that when you have to solve for the variable, you can end up with multiple solutions. Okay? In 8.1, the number of solutions you're going to get was at most 1. Or you got either a consistent or inconsistent equation system, or basically you got a dependent equation. So here you could have a countable number of solutions, like 2 solutions in this case. So now, like I said though, you got to be careful. You're given the system. You're not going to be able to graph them every time. Okay, so you got to be careful with that. And so you're not going to know exactly how many solutions there are going to be. So you're like, well, what would have happened if this parabola and this line did not intersect at all? Well, what would happen then was you would have got an untrue statement, for example, much like what would have happened back in the other section. You'd have got something that doesn't equal to something, or you would try to solve a quadratic equation that had an imaginary solution. So you could have an imaginary solution, and that's not real. So that's kind of the indicator here when the system is going to be inconsistent. So on that previous slide, let's go back to that previous slide. We got to 2x squared plus minus 3x minus 2. When you got to that point right there, and if it didn't factor, and then you tried the quadratic formula and the solutions were imaginary, that means the solution would be inconsistent because the two graphs would not cross. But not here. They actually factored, and you got x equals negative 1/2 and x equals 2. So these two graphs actually do cross. Okay, But if they had not crossed, you would have got a complex solution in that situation. Okay? So that's how it goes. And but like I said, it's kind of repetitive. Sometimes people don't teach 8.6 because they teach 8.1 because the techniques are very similar. But I like showing you how the two equations create a quadratic equations, which means you could have multiple solutions. Okay, but otherwise they're pretty much the same thing. So if you have any other questions, you want to see another couple examples or so, you feel free to contact me. And as always, you have a good day.